Now, one thing that I do want to bring up as you guys go through these video lessons is please feel free to pause and try these questions on your own, much like if you were in class, and then that way you can look at the solutions and at least you get that chance to give it a try. So, example 2. For each of the following, identify their horizontal and vertical asymptotes and any points of discontinuity. Starting on my first one, we can see that, well, I can't really factor anything there. It's going to be 2x minus 1 all over x plus 7. We can also see that nothing's going to cancel. So my point of discontinuity, whoa, why did I write a B right there? Whew, rough morning. So my point of discontinuity, we're not going to have any. Why? Because nothing cancels, nothing gets removed. From there, my vertical asymptote. My vertical asymptote is going to occur when the denominator, or the bottom, is equal to 0. So my vertical asymptote is going to occur at x equals negative 7. The next one, looking at my horizontal asymptote, I see that my numerator and denominator have powers that match, or rather they have degrees that match. So dividing my lead coefficient, my horizontal asymptote is just going to be y equals 2. Again, feel free to pause if you want to try this next question, but I'm just going to keep on rolling through these bad boys. So, what we do right here is I factor the top. I get x minus 3, x plus 3, all over 3x plus 2. And I just use difference of two squares for my factoring. Now again, we'll see that nothing has canceled off here. So my point of discontinuity, I don't have one. There's no point of discontinuity. My vertical asymptote is going to occur when the denominator equals 0. So what value will make that denominator equal 0? Well, let's just quickly sketch it out right here. 3x plus 2 equals 0. Sorry, my pen stopped working for a second there. So I get 3x equals negative 2, or x equals negative 2 over 3. So my vertical asymptote is going to occur when x equals negative 2 over 3. Again, sorry guys, my pen's getting a bit touchy here. Then my horizontal asymptote, we notice that the top degree is larger than the bottom degree. And when the power on top, or rather the degree on the top, is larger than the degree on the bottom, my horizontal asymptote, we just very, very simply say that it doesn't have one. Continuing on, x squared minus 3x minus 4 all over x minus 4. So the first thing that I'm going to do is I'm going to factor the top. Factoring the top, we need two numbers that multiply out to negative 4 and add up to positive 3, or negative 3, sorry. So that's going to give me x plus 1, x minus 4, all over x minus 4. Oh, what do we have right here? Switching my pen color up ever so quickly, we get a cancellation. And getting that cancellation means we're going to have a point discontinuity. Finally, the point of discontinuity gets to come out and play. So, vertical asymptote, well, my only thing in the denominator canceled out, so my vertical asymptote, we're not going to have one. Then, my horizontal asymptote, the power on the top, or the degree on the top, is greater than the degree on the bottom. So again, we're not going to have one. Wait for it. Wait for it. My point of discontinuity. The x minus 4 factor canceled off. So that means that my x value for my point of discontinuity is going to be 4. Then my y value will occur from putting the 4 into this right here. So I'd get y equals 4 plus 1, or I'd get y equals 5. Thus, my point of discontinuity will occur at 4, 5. Finishing off on our last question, we have something that's slightly different going on right here, where we have the 5 all over x squared plus 3x minus 10 all plus 4. Now, if you guys remember from before, all that I've done is I've put this in a slightly different form. You could combine the 4 into the fraction, but you really don't have to because we're not looking for any information at this point where we're going to need to use that. So what I'm going to do is I'm just going to factor the denominator right here. I get y equals 5 all over plus 3 minus 10, so two numbers that multiply out to negative 10 add up to 3. So it'll be x plus 5, x minus 2, and then that will all be plus 4. We again see that I don't get any cancellations, so we're not going to have a point of discontinuity. My vertical asymptote is going to be at negative 5 and at positive 2. Now, my horizontal asymptote. If I were to take this 4 and I were to put it back into that fraction, that 4 would become attached to that x squared. Or, if you remember from the previous lessons, when we have that plus 4, we can just simply say, well, that's going to be my horizontal asymptote. So I get it at y equals 4. And again, the reason this is occurring because we're in a slightly different form than we had in our previous questions. Then, finally, my point of discontinuity, well, nothing canceled off, so again, we don't have a point of discontinuity. I hope you guys enjoyed these examples. If you check out the next video, we're going to get to the next examples.